So this is my little coaching video for these problems. Here we go. Problem number 1. You have sodium carbonate reacting with phosphoric acid. So you need to write the chemical equation for that. You will recognize that it is a double replacement reaction. The sodium will go where the hydrogen was. The hydrogen goes where the sodium is. Don't forget to write the formulas correctly on the other side. You have 120 grams. You need to change that to moles. You have 2 liters. There's 3 moles per liter. So you need to change that to moles. That's real simple because it's 2 liters times 3 moles per liter, so it's 6 moles. Okay, it's at 780 millimeters of mercury and 20 degrees C, and the resulting gas is collected over water. So you're going to need to find the number of moles of gas that are produced. Let me say that again, the moles of gas that are produced. Remember that the carbonic acid that will be produced. So you'll get H2CO3 on the right side. So go ahead and write the equation so you know that. You won't follow this unless you write it down. But anyway, we said the other day that H2CO3 always breaks down into water and carbon dioxide. Remember that when we mix those chemicals in the last little lab we did with the mystery mixtures, that when we mixed them together we got some fizzing. The fizzing is carbon dioxide. So the gas that's produced is carbon dioxide, and it's collected over water. So don't forget that when you do PV equals nRT, after you know the number of moles of gas, you'll use PV equals nRT. After you use PV equals nRT, then, or when you use PV equals nRT, you will need to subtract out the water vapor pressure, and so you won't use 780. You'll use 780 minus whatever the water vapor pressure is at 25 degrees C, and that's on that chart. If you've lost your chart, it's listed in Google Classroom under the gas problems and resource materials. Alright, so that's number 1. Number 2, you're looking to make 25 milliliters of gas, so this time you need to change that 25 milliliters to moles. Because anytime you do a stoichiometry problem, it's changed to moles, do the mole ratio, and so on. So you need to change your 25 milliliters to moles. To do that, of course, that's 0.025 liters. And if you're watching this video, I'll assume that you can skip the combined gas law method right here and just do letter B. So change your 0.025 to moles using PV equals nRT. It says it's collected over water, so 105 kilopascals will not be the pressure you use. You will need to subtract water vapor pressure. I think the water vapor pressure table may actually be given to you in millimeters of mercury, so you may have to change millimeters of mercury to kilopascals. That's no big deal because you know that 101.3 kilopascals is the same thing as 760 millimeters of mercury. So there's an equivalency for you, and do the conversion. So you can convert whatever the kilopascals are into millimeters, or whatever the millimeters of mercury are into kilopascals. Okay, here we know the pressure is 16 psi on number 3, and we're looking for volume of gas. So 16 psi needs to be changed into a unit of pressure that we have, where we have water vapor pressure. So our water vapor pressure is in millimeters of mercury, so I just go ahead and change this 16 psi to millimeters of mercury. You know that 14.7 is standard pressure in psi, so 14.7 psi would be equal to 760 millimeters of mercury. So make that conversion. It's 25 degrees, so that would be 298 Kelvin. All right, now if you collect it over water, you have 50 grams of ammonium sulfate, 50 grams of aluminum hydroxide, so you have to write the equation for the reaction of ammonium sulfate and aluminum hydroxide. When you do that, the 50 grams are going to, you know how to do limiting reactants. So figure out which one's limiting, then calculate the moles of gas, and once you have the moles of gas, you can find volume using PV equals nRT. There is one weird thing. The gas is going to be ammonia, because ammonium sulfate, when it reacts with the aluminum hydroxide, it's going to make aluminum sulfate. So unfortunately this is a PDF file and I can't write on it, but it would be ammonium sulfate. No, I'm sorry. Ammonium sulfate reacts with aluminum hydroxide. It's going to make ammonium hydroxide, is what I'm trying to say. So ammonium hydroxide. Ammonium hydroxide is NH4OH. It never stays together when it's produced. It's kind of like carbonic acid that I just talked about. H2CO3 always decomposes into water and carbon dioxide. Ammonium hydroxide always decomposes into NH3 plus H2O. So you're going to see, I'd go ahead and write the equation with the product as ammonium hydroxide. And I think when you do that, you'll end up with 6 ammonium hydroxides. Is that right? Let's see, ammonium sulfate, NH42. That's going to be OH3. So it'll be Al2SO43, SO43. I think you're going to have 6 ammonium hydroxides. When you have those, they're going to decompose into ammonia, 6 NH3s and 6 H2Os. So know that when you write your equation. Number 4, aluminum carbonate decomposes into aluminum oxide and carbon dioxide. This is not a double replacement reaction, so I'll go ahead and tell you the products. So when you heat a metallic carbonate, you always get a metallic oxide and carbon dioxide. This is a metallic carbonate, metal, carbonate. So you're going to get a metallic oxide and carbon dioxide. Alright, so you want to make 40 milliliters. You're collecting it over water, so you got to use, you're going to subtract the water vapor pressure at 23 degrees. I would use PV equals nRT to find the moles of carbon dioxide, and then work backward to find moles of aluminum carbonate in grams. On this one, how many liters can be produced by the reaction of the 24 grams of manganese dioxide or manganese 4 oxide with hydrochloric acid? So you know manganese 4 oxide plus HCl is going to make MnCl2 plus water plus chlorine. Chlorine, remember, is diatomic. So balance the equation, and you know the temperature, you know the pressure. It doesn't say anything about collecting over water, so you don't have to worry about water vapor pressure this time. So use PV equals nRT and solve for moles. Oh no, I take it back. So you got 24 grams, you're going to start with that. So you change grams of manganese 4 oxide to moles. Then do the mole ratio between chlorine and that, and then use PV equals nRT once you have moles of chlorine to find the volume of chlorine. On this one, I'm going to stop here. I'm going to do another little video. The second little video, I'll start with this one. This is going to take me a minute to explain it. It's easy, but it takes a minute to explain it.